This was a difficult question. Question 11, only 2 of you got it correct. Answer is A. First of all, turn the information you have, which is up here, into this. So we know the length of x is twice the length of y, and we know the diameter of y is half the diameter of x. So let's think about stress first. Stress is force over area. We know that they both have the same load, so the same force. So this is constant. But we know that the diameter of y is half the diameter of x. So which row is correct for y or y? Well, we know that y is therefore going to have a quarter. We put half into area. Remember, area is pi r squared. We need to square this relationship. So we know that it's going to be a quarter of the value. So a quarter of 2 is 0.5. We're at 50-50 at this stage. So you could always have a guess, but let's have a look at extension. Now we know they're the same materials, they have the same E. And a reminder that E, Young's modulus, is stress over strain. Now remember, strain is x over L. Now if we rearrange that, we get x is equal to the stress times L over E. Now E is constant. So what happens to the extension of y? Well, we know the stress is a quarter, so a quarter goes in here. We also know the length of y from up here is half the length of x. So relative to x, expect it to be a quarter and a half, i.e. an eighth of the extension, given that e is constant. So 4 divided by 8 gives me 0.5, so that gives us our answer. Difficult question there. Question 10 wasn't answered very well either. Now, first of all, we can rule out 2 because let's just think about it. It's the same material, same tension, and remember stress is force over area. So it's the same tension, this is constant. So really the only thing that's going to affect it is area. Now, just think about a thick and a thin piece of string. If they've got the same force, which one's going to have more stress? Well, obviously the thinner one's going to have more stress. There's less material to take that force. So we expect our answer to be less than 1 because we expect the stress in the thinner to be bigger than this one at the top. So smaller divided by bigger, so we know it's either A or B. Again, it's 50-50 at this stage. Now, how do you get your actual answer? Well, it's got 4 times the radius. If you have 4 times the radius, remember that area is actually pi r squared, and that's what's in the equation. So it's actually 4 squared is the factor. So we put 16 in the bottom, so relative to the top is 1 over 16. That gives you an answer of A. This one wasn't great either. So what is the value of x, which x is the compression or the extension, but the compression in this case. Now up here it's going to have GPE. Let's calculate the ng at the top because that will all become elastic potential ng at the bottom. So 0.22 times 9.81 times by the height 0.4. So if that's the ng at the start, the GP, it's not moving, it's at rest, so that's the only ng at the start. That will all become elastic potential ng at the end. Remember, elastic potential ng is equal to half Fx, or if we substitute in F equals Kx, and again you should just know this, it's equal to half Kx squared. Now that's useful because we're given K, force constant is K, and therefore we can find X by equating that to this. So this just comes down here, and you can then solve that to get your answer. Question 1 wasn't answered too well. I've started by just writing out the equation that you need to learn for E, Young's modulus. It's equal to stress, which is F over A divided by strain, so you get that equation. Rearranged for F, because F is tension, is a useful way to have that equation. Now let's just compare the two. Let's start with y at x. So the y at x has twice the Young's modulus, so this is times 2 over here, and the diameter of y-axis is half that, so it's half the diameter. Remember, that's going to mean the area is going to be a quarter because of pi r squared. You can see they love that little trick there. So we put that factor into there. We know it's going to be times 2 and a quarter relative to y. So it's going to effectively be half over 1 relative to y. So you get an answer B.